In this video, I want to give an example of matrix multiplication. So let's start off with our A matrix. And let's suppose it's of dimension 2 by 2. We always give the number of rows first, followed by the number of columns. So A is a square matrix. And let me make up some elements here. Suppose we have -2, 1. These are the first row elements. And in the second row, we have the elements 3 and -1. And I want to look at another matrix called the B matrix, which will be of dimension 2 by 3. 2 rows and 3 columns. So again, let's come up with some elements here. 3, 0, 2, -1, 3, and -4. And now let's consider the matrix product AB. And it's always a good idea to write the dimensions of the matrices under the letters or the symbols for the matrices. So again, A is of dimension 2 by 2, and B is 2 by 3. Now, the question we have to ask ourselves is, are these matrices conformable for matrix multiplication? Can we multiply them together, where A is the lead matrix and B is the lag matrix? And the answer is yes, these two matrices are conformable for matrix multiplication. We can multiply them together because the two inside numbers are the same. The number of columns of the lead matrix A is equal to the number of rows of the lag matrix B. So we're going to get a new matrix. You could call it matrix C or matrix D or E or whatever. But what will be the dimension of this matrix product? Well, it'll be of dimension 2 by 3 because of those two outside numbers we have. The new matrix we get will have the same number of rows as the lead matrix A, and it will have the same number of columns as the lag matrix B. So when I multiply these two matrices together, the new matrix I'm going to get will be of dimension 2 by 3. And I like to put placeholders in this new matrix I'm about to derive, just to remind me that I have to put in elements where these placeholders appear. So I'm going to have 2 rows and 3 columns. Okay, let's go to the element in the first row, first column of the product matrix. What will this element be? Well, since this is the first row, first column of the product matrix, I take the first row of the lead matrix and the first column of the lag matrix. And then I have to sum up the products of the elements. And this is how I do it. I'm going to go -2 times 3, which is going to give me a -6. And then plus is always plus, because it's the sum of the products of the elements. 1 times a -1, which is a -1. So let's put here plus -1. And of course, that's going to be -6 -1 or -7 eventually. Okay, the next element I want to calculate here is in the first row, second column of the product matrix. How do I find it? Well, since this first row, second column, I use the first row of the lead matrix, but this time the second column of the lag matrix. And then again, I have to sum up the products of the elements. How do I do it? I go -2 times 0, which is a 0, plus 1 times 3, which is 3. Let's go for the next element, first row, third column. I use the first row lead matrix, this time the third column of the lag matrix. So I'm going to go -2 times 2, which is a -4, plus, it's always plus, 1 times a -4, which is a -4. So that's actually -4 plus a -4, which is going to be -8. Let's get the next elements. This element is in the second row, first column of the product matrix. How do I find it? Second row lead matrix, first column lag matrix. 3 times 3 is 9, plus -1 times a -1, which is a 1, so that element will be 10. Let's go to the element in the second row, second column. How do I find it? Use the second row of the lead matrix in the second column of the lag matrix. So I'm going to go 3 times 0, which is 0, plus a minus 1 times 3, which is a minus 3. So it's going to be plus minus 3. Just call it minus 3, if you will. And the last element, second row, third column. I use the second row lead matrix, third column lag matrix. So go 3 times 2, which is 6, plus a minus 1 times a minus 4, which is a plus 4. So let's just see if we can figure out what each of these elements will be in this product matrix. Minus 6 minus 1 is minus 7. 0 plus 3 is 3. Minus 4 is minus 8. 9 plus 1 is 10. 0 minus 3 is minus 3. And 6 plus 4 is 10. And here is our matrix product, AB, which is of dimension 2 by 3.